That's on call. You're on call.
Where is it happening?
Yeah. Maybe. Can you see the board, all of you?
Yes, sir.
Okay. Where did you start recording?
Yes, sir. I started the recording.
I'm not able to see the poll. I'm able to see the picture, hung picture. How come? Is the board visible?
Yes, yes,
Yes.
yes.
The board is visible, sir.
I'm not able to see it. What happened, Mali? I'm not able. Chalo, no issues. You're able to see, right?
Yes, sir.
Yes.
Okay, and you're able to record as well, right?
Yes, sir.
Okay, let's get started then. Now, we were dealing with electrostatics and we covered for shell and sphere both. Correct me if I'm wrong. Did we cover for shell? Did we cover for sphere? We haven't, or we have.
So I do not recall us doing that.
So we are through ring, are we?
Yes, sir, we are through ring.
We are through disk, are we?
So disk.
Disk.
So I do not remember. Maybe Vibha does.
Please do check. What about you? What about you, yeah? Did I take disk with you or not?
So,
Not waiting for it.
so I personally did it when I was solving the question you gave. So I am through it, but I do not know if you took it in class.
Vibha, then if you're through it, then we'll move beyond it. Let me go beyond it in that case. Okay. Check and accordingly tell me what shall I do in quick succession. If you want to, then I'll be taking it. If not, we can move for shell and then sphere. Shall we?
Suppose we can. Sure, sir.
Okay. I'm taking shell then. Fine. But that was very important. That disk one is very important because from this we get what will happen when either x is tending to 0 or r is tending to infinity. So far as my memory is to help me on, I'm jogging down it. What it is helping me on is certainly I have taken with the mention of x tending to 0 or r tending to infinity. Correct me if I'm wrong because I've been taking class at different places. It may have got jumbled. Taken or not with you? Not? Vibha, why aren't you speaking, man? Speak, take, check.
So we're doing the
Question goes to all, right?
Yes, sir.
Then if you were removed of what being taken in the class, then what's the purpose of class?
Yes.
Please get prepared, Vibha, when coming for class. I'm taking this right down. Let us take a disk. Let us take a disk of radius r. Let us take a disk of radius r. Don't use water. Water is no help. Let us take a disk of radius r with surface charge density sigma. Let us take a disk of radius r with surface charge density sigma. Find field and potential. Find field and potential at a distance. X from its center on its axial point. Find field and potential at a distance x from its center on an axial point. Of course, axial point we are now very much aware of what we can do, where we can find. So I'm limiting it to the axial point. Here there is a departure we can find other than axial point as well, but that is only one with us. I'll come to that in the form of question. To begin with, we are finding on the axial point. The point that we are trying to suggest is an axial point. Got it here?
Yes.
So this is the disk for me. This is the disk for me. This is the axis. This is my x-axis, let's say. This is y. And this z. I hope the
So there's a lot of feedback.
something. Copy device. Remember?
Not
You guys?
yes.
Have you guys there? So this is the disk. This is the disk. This is a disk with what surface charge density? Sigma. Where I have to find potential over here is a point P. What distance? 0, y, 0. This is my y-axis. Okay, yeah?
Yes.
0, y, 0.
So we can't hear you. So again, we can't hear you. We're only hearing static.
Can you see me? This is happening. I think I'm getting feedback from. I'm not able to. It's my device. Can we mute ourselves? Tandem. Viva, can you mute first?
Yes, sir.
Saktam, mute yourself. Yes, Saktam, it is your noise. Be on mute, Shaktam. Okay. Fine. Shall we move ahead?
Yes.
Vasudev and Vibha, you can both can be up.
Yeah.
Guys, now we addressed. Okay. Okay. Can you see the board now?
Yes.
Zero, right? Okay. Now what I'll do, I'll cut it into rings, as you know, because we are coming from ring. We know everything about ring, correct?
Yes, sir.
So what we should do, we should make good of rings, correct? We'll cut it into rings, small rings. And because of each ring, I'm privy to what will be potential, correct, dear?
Yes, sir.
We have the formula. If you can recollect the formula for any ring, what potential we do generate, it is that amounting to 1 by 4 pi epsilon naught q divided by r square plus x square raised to the power half. It is our potential, right?
Yes, sir.
So what we'll do over here, we'll take a ring of certain radius. I write radius of that ring as zeta. And thickness of that ring as d zeta. Why is thickness required over here? We require area. Why is area required over here? It's an areal distribution, correct?
Yes.
We need to assign with ring. I need to get you back to the memory lane wherein I did say, which I'm by the way over here eating or backtracking from. What did I tell you about ring is? A ring is a distribution which is linear, correct? I'm digressing from that process. I'm digressing from that understanding. I am not taking ring anymore. I'm not taking ring anymore to be a linear structure. Instead of linear, what I'm associating with it is an area. Why? Because I have to juxtapose it to disk. I have to juxtapose it with the distribution at hand. And distribution at hand now is surface or areal, correct? So the element which I'll have to take, any element which I'll be taking, must be in agreement with the distribution out here. Element which I am taking certainly is ring, will associate thickness with it to make it in juxtaposition with what we have over here, incommensurate with it. So incommensurate with it, by that what I mean, area of this ring will accordingly be marked 2 pi zeta into d zeta. Agreement, yeah?
Yes.
Okay, this when multiplied with sigma will get me charge. This is the charge on the ring, a ring of radius zeta. This is the charge on the ring of radius zeta. You can mark it dq. You can mark it dq. This is dq to us. So what dv will get generated? Very obvious, 1 by 4 pi epsilon naught as it is. Now q, instead of q, what will I write is sigma into 2 pi zeta d zeta, right there. Do check.
Yes, sir.
And divide by what do we have? Zeta square plus x square raised to the power half. Find here. Find all of
Yes.
you? Okay. This is due to a ring of what radius? Zeta, with which we have associated area. We did associate area by taking or associating thickness with it. Area multiplied with sigma got us charge. Charge is what we are reflecting in numerator. Denominator, we are just to multiply with distance, which is what to us? Zeta square plus x square raised to the power half. This gets us potential. Once we got potential, we are aware of that parameter which we are to integrate on will certainly be zeta. Are you all in agreement with this?
Sure.
Please be aware of x is not changing. I'm not changing x. I'm not changing point of consideration. X remains.
Yes.
X remains. Point of consideration is not being changed. What is to be changed and from where to where is to be changed zeta. From where to where? From 0 to capital R. So for potential, what we do, integrate over here, integrate over here. From where to where the integration is to apply? From zeta is equal to 0 to zeta is equal to capital R. Capital R is the radius of disk. Please tell me what will you be getting? How will you go about this integration?
So
How can we go
trigonometric
about this
substitution.
integration? Can we get the integration done? Very simple integration, by the way. Nothing much. Pretty simple in integration. What to do?
So
Can you
trigonometric
take in care of
substitution.
the denominator? Yeah, it's getting poor. I don't know. There's poor connection out here showing. Am I audible? Am I visible?
Yes, sir.
Yes, sir. You're audible. Yes, sure.
Okay. Can we take the denominator per se as a different variable? Let's say z. What's it?
Yes, sir. Then you can
Let's
use
take the
substitution. Yes.
Yeah, we go by substitution. You can take any other substitution. You can go by trigonometry, no issue.
Mhm.
Objective over here is integration. What is coming to me that over here you are having zeta d zeta. So if you take z square, it will work. Z square is what to us? Is zeta square plus x square, right? So twice of z dz will be what to us? Twice of zeta d zeta, correct? 2 and 2 gone. So dz is removed by zeta d. Please do check. What then this can be marked? Sigma as it is, 2 pi as it is. You get over here z dz or z dz divided by under root of this. So divide by z, right? And from where to where z will vary. You have changed the limit, so please be very careful. These were the limits for zeta, not z. So when zeta is 0, z will be x, right? Zeta is 0, z will be x, correct?
Yes, sir.
Correct?
Yes,
Yes,
sir.
sir.
Vasudev?
Yes, sir.
And when zeta is capital R, then what will be z?
Under root r squared plus x squared.
What will be z? Capital R square plus x square under the root. Do check. Fine.
Yes, sir. Affirmative.
Is it good? Am I audible here?
Yes, sir.
Sir, I'm unable to see you, sir.
I am not getting any response.
Yes, sir. You are
Please get me a
audible.
thumbs up. Am I audible, Vasudev?
Yes, sir. You are.
Okay,
Sir.
Vibha has got me. Okay.
Same.
Please integrate and tell me what will you be getting the end result as. Then now nothing much left over here. 1z gone, right?
Yes, sir.
Not visible that side out. Integrate, please tell me what were you getting. 4 pi epsilon will also feature over here. 4 pi epsilon naught. Please see what you're getting by the time I clear the board.
Sir, I'm unable to see you,
The board is
sir.
in bad shape.
Sir, I'm unable to see
Please write
the.
whatever on board, I'm clearing it.
Sir, I'm unable to. Sir, I'm unable to see the board, sir. Sir,
Can I clear it?
I've sent a screenshot of the board in the chat. You should be able to refer that.
oh, okay.
Huh.
Yes.
It is on the damn board because of which it has got marks. It's not getting erased. Okay, so what did we get? Can you tell me what did we get by the time the board is getting dried? Speak someone, I'm not getting anyone, I'm not able to hear anyone. This is showing me a continuous poor connection. Okay, it's being removed now. Yes, please tell me what did we get? Vibha, what
Can you hear?
are we getting? Vibha, can you hear me? So tell me what did you get, the end result?
So can you hear me?
Sir, I'm trying to solve over here,
Yeah,
sir.
yes, Vasudev.
Yes, sir. So you get a 2k sigma under
I
root
can
r
hear you.
squared. Yes, sir. So you get 2k sigma under root r squared plus x squared minus r.
So sigma will feature 2 epsilon naught also will feature, right?
Yes, sir.
Bracket r square plus x square under root
Minus r.
minus x, is it so?
Um.
Is this what we are
uh,
getting?
Yes, sir, minus x. Sorry, my bad.
No? The continuous poor connection, don't know why, what is the issue today? Okay, is it so?
Yes, sir, it is.
Yes, dear?
So I don't think you're able to hear us. Can you?
Why is this happening? What is it today? Why the connection is poor today?
Did he leave?
Yeah, he left. He'll come back.
All right.
Is it better now?
Yes, sir.
Any luck?
Yes, sir. It's
Yep,
better.
I hope it's better now.
So for us, it's
Okay,
better.
fine.
We don't know about you.
No, I'm good. I can manage. For you, it should be better. That's it. Recording is on, right?
Yes, sir. Recording is on.
So is it what we are getting? Tell me. Sigma by 2 epsilon naught r square plus x square minus x. Is this what we got?
Yep. Yes, sir.
Potential equation, correct?
Yes.
This is potential equation. I think you will be getting r square plus y square minus y, correct? Because I have taken my y axis out there, correct?
Yes, sir.
That was my y axis, right?
No, I don't. I think we were doing it in terms of x all along. So.
Okay, no, right was which axis? I took the point as 0, y 0, correct?
Yes, sir. But then it makes sense. It should be x, right? Oh, wait,
No,
we're doing it by.
it depends on axial point. If I've taken that side to be my y-axis, then it'll be y. Why will
Okay. Yes. Yeah.
why should it be holding on x? Right?
Yes.
Okay, so in our case, this will not be x, this will be y. R square, y square minus y. Please do make that change. Okay, next is what will be ex, what will be ey, what will be ez. So ex will be this, you're aware of it. And as it doesn't depend on x in our case, so ex will be 0. Ey will be partial derivative of b with respect to y. Let's differentiate it with a negative sign. So sigma divided by twice epsilon naught will remain 1 minus what we'll be getting? Tell me, dear.
So y by under root
Okay, under root r
r
square
square.
plus y square into 2y, correct?
Yes, sir.
Right? Into 2y. This is what we'll be getting for ey. Ez will also be 0. It doesn't depend on z. So ez is also 0. What then? Only ey, and what is that to be marked? Twice epsilon naught, important one now. 1 minus y divided by r square plus y square under the root. Do check, please. Fine?
So you've crossed the bounds of the camera.
Okay, fine. Sigma divided by twice epsilon naught, bracket open, 1 minus y divided by r square plus y square under the root. Do check and endorse.
Yes, sir. IFM.
Okay, if this is the case, if this is the field, then you're well aware of what will be the end result if you assume y to 10. I take two cases, tending y to 0 or r to infinity. Find here, they are same.
Yes.
Either you say that you're able to view the edges of the palm now, but will not be if it is brought very close. If not, then palm is appearing to be infinitely spread. That is what is ostensibly appearing to us. Palm will appear ostensibly to be infinitely spread. Why? Because I am tending y to 0. So either you are to say y to 0 or analytically r tending to infinity. Whichever you take, you're aware of this part will reduce to 0, right?
Yes, sir.
So if the disk is infinitely spread, then what field do we get is sigma divided by twice epsilon naught. Okay, dear?
Yes.
If the disk is infinitely spread, then what field do we get of the disk which is infinitely spread is sigma divided by twice epsilon naught. Point to note, it is independent of y, it is independent of xz of course, but is also independent of y in this case. And if it is independent of y, this is a field which can deem to be constant. Fine. It's a
Yes.
field which can deem to be constant. Remember, this concept will be used when we next go to capacitor. Because in capacitor, we place the plates very close to each other. We assume field to be constant. Fine?
Yes, sir.
Okay, so this is field owing to disk. Owing to disk of certain dimension, and then owing to disk of infinite dimension. After the disk, we do have shell. And then we have sphere. Shall we take them in quick succession?
Yes, sir. Sure.
A bit of integration required. So if you want to just make a slight departure to make it more interesting, I may go on with the dielectric capacitor and return to it. Completely your take. If you want to get done with the configuration, so be it.
Sir, I think both of us have already done the shell and sphere and the related electric fields and potentials. Maybe you can move on to capacitors. That's my
Sure,
take.
shall we, Viva? Are you good with it?
So can we go through the shell and the sphere?
Okay.
Ready.
In that case, let us take quickly. Sphere. Actually, a bit of calculation. That'll be mundane. That's the reason I asked for it. No issues. I'll make it clear to you. You can further with calculations. Fine.
Okay, so
What we do for a shell is an obvious. Tell me, what will I do for a shell? If I am to take shell, what will I do in order to calculate field and potential? Coming from what we are known to all of you. Coming from ring we are, correct? Coming from a ring if we are, then what shall we do for the shell? Come on, let me know. What shall we do for a shell to make good of our previous, to make good of baggage that we are carrying? Yes, tell me, Viva. What shall I do? This is the shell to me. This is the shell to me. What shall I do? Come on, tell me quickly, dear.
Sir, the point on the surface on the
I'm carrying a baggage. I told you I'm coming from the understanding of rings. So how can I make good of that understanding? How can I make good my ring understanding? Yes, please. What, Viva? I need to speak, Viva. I need to now comprehend things. Writing examination. Please be attentive now. Luxury time off we are. We don't have any more leisure. We will, of course, get rings, correct? We will cut it into rings, right? Vasudev?
Yes, sir.
We'll cut it into rings. And when we cut it into rings, what we have to show, where we need to find potential, where we need to find, let's say here, this is the point Px00. I'm taking this to be my x-axis. Just to be in unison with what in general they do. Just in unison with what in general they do, what I've taken this axis to be my x-axis. This is the ring that I have taken. A ring which is subtending what angle at the center? I'm marking it to be theta. The radius of sphere, capital R. Got it, dear?
Yes, sir.
yes, sir.
This again is surface distribution, correct? So what I'll have to get of the ring, the element, I'll have to get area of the element. What will be area of the element? Tell me. Area of the element will be 2 pi. And what is R over here? R of the ring? R of the ring is R sine theta. 3 minutes. R of the ring is R sine theta. Yes or no? Capital R sine theta, right?
Yes, sir.
Yes, sir.
So 2 pi capital R sine theta is the perimeter. Perimeter will be multiplied with thickness. Thickness on the periphery is R d theta. Thickness on the periphery, how much will it be? R d theta. This when multiplied with sigma will get me charge. What charge? dq. I write dq for it. Fine? Fine?
Yes, sir.
Yes, sir.
Now for potential. Let me take this small r, small amount of potential. What will it be? 1 by 4 pi epsilon naught as it is. For charge, we write sigma 2 pi multiplying r square sine theta d theta done. This is dq. Divide by small r. Do check there. This potential equation. Divide by small r.
Yes, sir.
Now, small r, capital R, and theta, they share a relation. You are aware of it. Tell me what relation that being correct. You are aware of this distance is x, this distance is capital R, this distance is small r. So you can help me
Sir,
write cos theta. What
sir,
we call theta, capital R square plus x square minus small r square divided by twice capital R into x, right? So small r from here, capital R square plus x square minus of 2 capital R's into x cos of the angle theta whole under the root. Clear, dear of you?
Yes, sir.
sir, I'm unable to
Am
see
I
the board.
clear?
Sir, I'm unable to see this
Am I
board, sir.
clear?
Sir, I'm
Sir,
unable to
web
see
is
the board,
facing.
sir. Just a minute, sir.
Not able to hear anyone. Respond please or show me your thumb.
Sir, I'm unable to
Can I have a
see
thumbs
the board.
up? Clear?
Sir, I'm unable to see the board, sir.
Not able to see either. Is it clear? Can I further?
So your voice is choppy.
For quite some time, I'm into a monologue, it seems. Yes, Viva, is it clear?
Sir, it is clear now, sir. I was unable to see
Can I
the
get a
board.
thumbs
That
What how will you see? Okay, clear now?
Yes, sir.
Is it
Yes.
clear, Vasudev, clear board?
Yes.
Viva, clear
Yes, sir, it's
board?
clear.
Yes, sir.
Okay, now you write the value of small r there. What we do next? We finish for small r. Because small r for me, I'm removing now. Small r removed. Instead of small r, what do we have? Capital R square plus x square minus 2 capital R x cos theta raised to the power half. Okay, just to integrate now. We are to integrate now. Integrate from where to where? From where to where? Theta equal to 0 to theta equal to pi. Can you say that?
Yes, sir.
Integration from theta is equal to 0 to theta equal to pi. That is what we have to execute. And I'm much in, I won't say every other time, no blanket perception there, but much in favor of taking yet again z square as the term in denominator. Okay, another variable is coined. What that variable? Z or z square. So what is z square taken? R square plus x square minus 2rx cos of the angle theta. 2z dz then will be r square constant, x square constant minus of 2rx cos theta will be minus sine theta into the theta. I think I'm not beyond the purview of camera. Am I?
So actually, you are.
I'm beyond the ambit of camera. If I'm beyond the ambit, then let me tilt it a bit. Okay, just check if it is visible, else I'll rewrite. Not visible?
Nope.
Not visible, I'll rewrite. No issues. Okay. Okay. I don't want to disturb the positioning of camera today. There's some network issue and I have lost already 2 to 3 days. I don't want to lose any further. So I write down for you z dz over here is equal to what to us? Minus of 2rx minus sine theta d theta. Okay?
Okay, sir.
Yes, sir.
Yes, sir.
Okay. Now help me position it in my equation dv. Sigma I keep as it is, right? 2 pi r square also I keep as it is. Now sine theta d theta.
So won't the two cancel out? Won't it be ZDZ equals Rx sin theta d theta?
Which one?
Yes, sir. The
We
two
wrote
doesn't.
2 ZDZ equals to Rx sin theta d theta. So ZDZ will be Rx sin theta d theta.
Ah, yeah.
That's
This
the-
will not be there. You're right. This two will not be there. You're right. Thank you. This two will not be there. Okay. Now what do we do over here is sigma as it is from here 2 pi r square as it is, correct?
Yes, sir.
Yes, sir.
Instead of sine theta d theta, what we can do is z dz divided by rx, correct? What left?
Sir, 1 second. Isn't it 2 pi r? When did it become 2 pi r squared?
No, there was one more. There were two r, right? R d theta and 2 pi r.
Okay, correct.
So 2 pi r squared z dz by rx and then this form. This form is z for us. So what we write over here? Z, correct?
Yes, sir.
Yes, sir.
Okay. It's gone, gone. What we're left with is sigma into 2 pi r square by Rx, and V will be nothing but integration, and that gets me Z. Now this is important for us because I'll be taking one shot both the cases. In one shot, I'll be taking both the cases. By both the cases, what I mean, you'll get to know now. Now Z over here, what can be the lower limit, what can be the upper limit? You'll let me know. If I take theta equal to 0, I start with theta equal to 0, find here.
Yes, sir.
So then Z will be, and this is carefully to be noted, R minus X the mod. Please do check. Same page. If I take theta equal to 0, then this becomes 2Rx, and then Z will be what to us? Plus minus R minus X, correct?
Yes.
Yes, sir.
Yes, sir.
Okay, that will depend on where is X. X can be less than capital R, X can be greater than capital R. If X is less than capital R, then we are within the sphere. If X is greater than capital R, then we are beyond the ambit of sphere, correct?
Yes, sir, but why have you taken mod here?
Because here X can be either greater than capital R or less than capital R.
Yes, sir, sure, I get that, but what mandates the value of Z to be positive?
So what mandates the value of what being positive?
Why are you taking Z to be always positive?
More out here, why? Because if you go mathematically, right? I have to take Z, not Z square. What do we get Z square, Vasudev, is R minus X square, correct?
Yes, sir.
Correct.
Yes, sir.
So what do we Z from here? Z can be plus minus, right?
Yes, sir.
That's what I'm writing here.
Okay.
No, sir, but by writing mod, you're clearing that you're saying that X minus R is not possible per se.
It cannot be negative. That is what I'm clarifying over here. Z cannot be negative for us. Z is
Okay,
distance,
why?
right? What is Z?
So, as far as I see it, Z was just a substitution for a mathematical expression. It doesn't
Correct.
represent any physical quantity.
Correct. No, it does. It does, dear. R square plus X square minus 2RX, right?
Okay, it might, but then we're taking Z squared equal to that. How does that mean Z must be positive?
Okay, tell me what is, according to you, the value of Z? Z is a substitute, okay? Substitute for length, correct?
So if you try to interpret its physical meaning, yeah, but
I'm taking this only to get a known that Z, according to our comprehension, which is this, cannot be negative.
yes.
That one you're having a problem with, is it so? According to you, Z can be negative, is it so, Vasudev?
I don't know. I just want to know what stops it from being negative. I mean, the equations do work out.
Yeah. Not working there. Yeah, that. Am I visible?
Yes, sir. You
Yes,
are visible.
Let's see again. Fine, if I'm visible, so wait, I'm missing it out here. Okay, clear? I'm visible, right?
yes, sir.
Yes, sir.
Now, yeah, Vasudev, tell me. I have placed over here Z and gone, and I'm integrating. Now I have got Z over here. Now, issue being over here that why is that Z should be positive, right?
Yes, sir. Yes.
Let us take theta equal to 0, Vasudev.
Yes.
Okay? We begin with theta equal to 0. We get this, right?
Yes.
But this is Z square, right?
Yes.
I want to write Z. I get two
Yes.
cases.
Yes.
I get two cases. Case number 1, it can be R minus X. Case number 2, it can be X minus R. Agreement?
Yes.
Yes, sir.
When it will be R minus X? When it will be R minus X, R is greater than X, correct?
Yes.
And when will that be the case? Point is within the realm of sphere, correct?
Yes.
Case 2 will be X minus R. When you take X minus R, when X is greater than R, correct?
Yes.
Yes, sir.
And in this case, point is beyond sphere dimension, correct? So I'm viewing in that perspective. I'll take two cases. Else I'll have to go with the case 1 wherein capital R is less than X, and then case 2 where capital R is greater than X, whichever be the case, right?
Yes. So actually, I have another doubt here. We usually
Am I
study
clear?
that the
Uh-huh.
yes, sir. I might come back to that later, but for now, I think I have a more pressing doubt. We've learned that the potential inside a charged shell is constant, right?
Correct.
But then,
It will be a constant. You'll get a constant.
yes,
You
sir.
will get.
But the formula for potential we've got, it depends only on z, and z actually depends on what point you're taking inside. So
How come you're saying depend on Z, dear? There you are getting what? Let me place the value, then only you'll get to know. The lower limit is R minus X. What will be the upper limit? Upper limit will be R plus X, correct? Upper there we don't have any issue because upper will be positive, right? Positive, correct?
okay.
Now when you are within the sphere as you mark, you are within the sphere, then this becomes capital R minus X, correct?
Yes, sir.
So capital R minus X minus capital R minus X over here. Tell me what I get it. See whether it will be independent or not. Check for yourself what we are getting. Don't forget there is an X over here.
So this is the potential due to one ring. Is it? Wait.
This is the potential due to what you have integrated. From theta equal to 0 to theta equal to pi when you're integrating it, then you're referring to shell per se, correct?
Oh yeah. Okay. So this it's okay. All right.
So what do we get? Tell me and check, see for yourself. Sigma will remain, 2 pi will remain, R square, I'm keeping as it is Rx, X with the upper limit is R.
2 of 6 minus of
Visible?
6.
I'm removing over here. So what do we get the upper limit? Upper limit is R plus X, which I keep as it is, minus of R minus X lower limit. When I write R minus X, I'm assuming R to be greater than X. That means I'm within the sphere dimension, correct?
Yes, sir.
What do we get? Sigma 2 pi R square by Rx. And inside of the bracket, what we are getting? R plus X minus R plus X, correct? R and R gone. X over here and X over here, correct?
Yes, sir.
Yes.
What do we get from here? Sigma x to x, so 4 pi R square divided by R. X remains. You check. I think I have missed through and through 4 pi epsilon naught. Please incorporate it. 4 pi epsilon naught here. 4 pi epsilon naught over here. 4 pi epsilon naught here. I'll get 4 pi epsilon naught here as well. So Vasudev, is it not independent of x?
Yes, it is.
And that it should be. That is part of the course, raison d'etre. We were to prove it to be independent. It will be independent. Why so? Because field inside is 0.
Yes.
But we have not proved it as yet. We'll be proving it from here. Potential is constant. Inside of the shell, potential is constant. Correct?
Yes, sir.
Can we say that?
Yes.
Can we say potential is constant inside of the shell? Not getting anyone. Yet again.
Yes, sir.
Yes, sir. I'm not able to see. Not able to see.
Yet again an issue. Is it visible camera?
So the camera is frozen now. It's shaking and on the board is not
It's
that
now
much.
visible.
It's not that much. It's a bit blurry.
Yeah, I'll wait for it to get cleared. You'll have to bear with me today. I've also landed in the morning, so I was not able to go through the technicalities today. That is the reason. If you can please do bear with this day. Any luck?
Yes, sir. Now
Yes,
it is
sir.
clearing out. It is clearing out. So better.
Vasudev,
Yes, sir. I have a visual. It is clear. Can you hear me?
yeah, I can hear you.
Yes, sir. It's the board's
Any
clear.
further there?
Yes, sir.
So what do we get in terms of Q? Can we write it down? Q by 4 pi epsilon naught capital R. Am I right?
Yes, sir.
If we change sigma, what is sigma for us? Sigma is nothing but Q by 4 pi R square. So Q will remain, 4 pi R square will get cancelled. What do we get at the end is Q divided by 4 pi epsilon naught capital R. Do you have you all on same page? Q divided by 4 pi epsilon naught capital R. Yes or no?
Doing it. So,
There's nothing to be done by the way, Vibha. Q into 4 pi R square is sigma into 4 pi R square is Q, correct?
sir?
Sigma multiplied with R is Q, correct?
Yeah, yes, sir. Yes, sir.
So this is
Understood.
nothing but Q divided by 4 pi epsilon naught R, correct?
Sir?
What will it be? Q divided by 4 pi epsilon naught R.
Yes, sir. You do get that.
Yes, sir.
That is indicative of it being a constant. Agreement?
Yes, sir.
Yes, sir.
Okay, can you do for the next one? When we have to place over here, x minus r. This will change to x minus r. Can you check my index finger?
Yes, sir.
Yes, sir.
This will now change. This will remain. This will change to x minus r. Tell me what are you getting then? This changes to x minus r. Please be very careful, class, because what we are over here into discussion is integration, mathematical. They don't go for mathematical, they go for in general, I would say. Not painting with same brush. Never I do. In general, they will go for Gauss's theorem. After all Gauss's theorem, they will use to get these derivations. We will be doing it when we introduce Gauss's theorem. As of now, not being introduced. So it's completely in odds with Gauss's implications here. It's removed from it. It's for now, I'm not aware, enormous to Gauss's theorem. So I'm taking in complete odds with Gauss's theorem. This is immune to Gauss's theorem. This is mathematics. Fine?
Yes, sir.
Tell me what did you get when we take r x minus r here?
So you get 4 pi sigma r squared by x.
So that is
Wait,
depending on x.
Sir?
That is dependent on x, correct?
Yes, sir, it is.
So what do we get is q divided by 4 pi epsilon naught x, correct?
Yes.
Q divided
yes,
by 4 pi epsilon naught x, correct?
Yes,
Yes.
sir.
Important takeaway. Can you tell me can you preempt? Can you preempt, Vasudev, an important takeaway?
So, well, I would say that the potential around charged spheres defined by a piecewise function which takes a constant value inside the sphere, but linearly depends on the distance outside.
So
Yeah,
for
inversely.
lying beyond the dimension of sphere, the sphere get reduced to a point charge. Can we say that?
Yes, you could say that too.
For points lying beyond the realm of sphere, for any point lying beyond the realm of sphere, the sphere reduces or acts a point charge located at its center, correct?
Yes, sir.
Yeah,
Yes.
this is important derivation which we get. Please make that statement. Right, the
So
body
you-
of being discussed. Yeah.
So your video's gone off.
My what is off? The camera is off.
Yes.
Yes, sir.
Now,
No luck.
No, sir.
okay, wait a minute. Let me try it out. Let's see if I can resurrect or resuscitate it. Resuscitation has been an onerous ask, quite taxing on me today, by the way. Still, I'll not let don't pull in the plug that easy. Unless completely hamstrung. The camera is not visible, you ought to say. It's not functional rather. But Skype is also not working. Better now? Do check.
No,
No.
sir.
No?
No,
No,
sir. You can't
sir.
see a video.
Change all of you. You are not able to see me now, right?
No, sir, we're not.
No, sir.
What is appearing? Blank. Okay. DP is appearing.
Yes, sir. Just your DP.
Oh,
Just a
very good.
DP.
Very good. Good enough. Visible?
No, sir.
No, sir. It is coming. I'm unable to see you, sir.
I'm able to see myself, yeah. Now what? I'm able to see all. Right, change myself as happening, man. What to do? I'm not able to identify the problem. I'm able to see myself, I'm able to see all of you. Sweet.
So
Which one?
I'll try leaving and joining back in.
Wait, check. Wait a minute. No need. Okay, take. It's on, it's on record.
Sir, can you see us?
Good.
Sir?
Change the device. Is visible now?
No, sir, it is not.
Nothing is visible.
So you're muted, sir.
So you're muted. So you're muted.
I think you got the message.
Ah, yeah. It's good now?
Yes, sir.
Yes, sir.
Okay. So this is what we are getting, correct?
Yes,
Q
sir.
divided by 4 pi epsilon naught x.
Yes, sir.
Indicative of it being reduced to a point charge for all the points lying beyond it. I would like to see a plot of it. Please get me the plot. Plot of potential versus X. Show me the plot. Show me for X 0 to infinity. X varying from 0 to infinity. Get me the plot X varying from 0 to infinity. Why I seek plot? I wish to know, is this function differentiable at X is equal to capital R or not?
So it's continuous, but certainly
no.
not differentiable.
Is this function differentiable at X is equal to capital R or not?
So it's not differentiable.
Differentiable?
It's not differentiable.
Sir, 1 minute, sir. I'm doing it, sir.
Is what I saying differentiable?
Not differentiable, sir.
Now this is not having voice in it. Not differentiable.
Yes, sir.
How did you get to know Vasudev is not differentiable?
So it has a very sharp point there. I mean, it's
So
continuous, but
how
certain.
will you represent it on the plot?
So
If a
I've sent an
function is
image.
differentiable, then on the plot, the transition should be smooth.
Yes, sir.
That is left of the point, right of the point under consideration. If I draw tangent, it should tantamount to one line, correct? And if it's not, then it should be with a jerk.
Yes, sir. The left and right hand limits do not equate.
So the plot will be of the kind, you have to show the jerk. It was this way going up to this point, and after of this, it is to act this way. But this transition is not smooth over here. You need to show the jerk. Before of the point in a this is the point in a consideration. So before of the point in a consideration, tangent will not be collinear with after of the point, which is ambiguous here.
Yes.
Point of ambiguity, the point which we want to test it on, is not getting me before and after. If a line drawn, it's not tantamounting to same tangent. So this will be the plot for it. Fine. Feel now quickly. Yes. You know now. Differentiate it. So feel inside of the shell will be 0.
Yes, sir.
And outside of the shell, Q divided by 4 pi epsilon naught x square. Correct?
Yes, sir.
Q divided by 4 pi epsilon naught x square. Let alone differentiability, this function will not be continuous. Correct?
Yes, sir.
This function is not continuous. Till x is equal to r, it is 0, and after of it certainly shoots. Shoots to what value? Q divided by 4 pi epsilon naught r square, and then descends. Descends faster than potential, correct?
Yes, sir.
That's it. I'll be keeping it to this today. There's a lot that I had to grapple with today. On technical front, of course. So let me see if we can stretch tomorrow. Tomorrow I will be going for a stretch. Vasudev will be free after 3, correct?
Yes, I will be.
Vibha, can you be early tomorrow? Because I'm not able to take up to 5:30. You have to get me some leeway somewhere.
So 5:30 only I can come home, sir. That's the only thing, sir.
That you can get me. If you have class, in that case, I will be taking with Vasudev and Shaktam, and I will be trying to repeat with you. If not repeated, you will be going through the videos.
Okay.
Okay, I have to make good of the time which I have lost owing to my engagement somewhere else. I require, say Sunday is not available owing to Vasudev. Saturdays or the other days are not available owing to you being engaged. So at least to redeem on the front, which I have lost, I require 2.5 hour extra. And also I have to position another math class. Oh, by the way, math class once done, you will be going for a test, Vasudev.
Test?
Yeah. Once it's through, once a class is through with whomsoever I'm arranging the best for you. Best limited to that topic, whichever topic will be taken. A best overhaul is difficult to get, you're aware of it. So I'll be arranging best suited to the candidate concerned, and that candidate, when is through the topic, you'll be taking test on that topic.
Sure, sir.
Okay, I need to test. Are you through the concept which I wanted you to? So tomorrow when we'll begin, it can begin with a test. Today it was planned, but there is some issue, some glitches that we are facing. So I'm postponing it for tomorrow.
So test as in a physics test or a math test?
Permutation, we are through probability, correct? The test on probability.
No. So last
Question
class what
from
we took
your
was.
end, there'll be question from our end.
So
It's
the last
an
class
open
what we
discussion.
did was sequence in series, not probability.
Not able to. Pratham, could you please help me on that?
So last class we did sequence in series.
Yes,
with
just a minute.
Okay, so.
Tell me.
So last class we did sequence in series with special emphasis on recurring relations. We didn't do probability.
So fine, then we'll be taking on sequence series, no issues.
Yes, sir. That would be preferable.
Okay. But when I say sequence series, it is not, let me tell you, let me make a disclaimer over here. It's not ostracized. Okay. It will not be ostracized. It can have question related to binomial expansion.
Yes, sir. I do understand that.
Okay.
Yes, sir.
Okay. Thank you both of you.
Thank you.
Thank
Thank you all.
Thank you so much.